today, I'll be explaining Dijkstras' shortest path algorithm. Dijkstras is a greedy algorithm used to find the shortest path from a source node to every other node in a non-negatively weighted graph. Note that no edge weights can be negative. It works on both directed and undirected graphs with a time complexity of O e log n using a priority queue. Before learning Dijkstras, make sure that you understand graphs, greedy algorithms, and priority queues. After, you may study a bit of optimization of Dijkstras or Bellman-Ford DP or Floyd-Warshall DP. Dijkstras is important not only because it's a very basic shortest path algorithm that works on weighted edges, but also because it can be used in real-world situations to efficiently find the shortest or cheapest route to take from A to B, where A and B are not necessarily connected directly. For each node in a graph, keep track of a current shortest distance from your source node. Let's call the source node A. So we have an array shortest distance from A. We also have an array previous vertex, which can be used to construct the shortest path tree. Basically, we just keep here is like letters in this case, right? So everything we set in the shortest distance from A array is infinity, except for A is 0 from itself. Now, here's an example with the algorithm. So we repeat until every single node is visited. Look at its neighbors, and check their current calculated distances. So A's current distance from A itself is 0. So we look at its two neighbors, B and D. So B is 6 away from A. So B away from A is 0 plus 6 equals 6. So 6 is less than what it was before, which was infinity. So we obviously take 6, and the same for D, we take 1, and we mark the previous vertex as A. Now, we mark A as visited, and we look at our shortest distance from A array. We take the minimum one that hasn't been visited yet. So A is visited, so we don't take 0. 6, infinity, 1, or infinity. Obviously, 1 is the least, so we go to D. Now at D, we look at its unvisited neighbors. So the neighbors are A, B, and E, but A has been visited, so we don't need to consider it. So looking at B, we look at 1 plus 2 equals 3, right? Because A to D is 1. We have it in our array. And D to B is 2. And we have it in our graph. So we know that the distance from A to B is 6. But it can also be ADB, which isn't direct, but it's less. So we take 3 instead of 6. And we mark the previous vertex as D for B. And we do the same for E. And 1 plus 1 equals 2. And 2 is less than infinity. Infinity is what it was before. So now we have this. We visit E because out of everything that hasn't been visited, B, C, and E, well, 2 is less than 3, 2 is less than infinity, so we take E. We look at E's neighbors, we do the same thing until everything is visited. And we have a tree made out of our previous vertex. And this is the shortest path tree that is formed. Once you understand Dijkstras' algorithm, the implementation becomes fairly simple. You can see here that after initializing these two things in our for loop, add every single vertex into our priority queue Q, which is sorted from least to greatest by distances from the starting node, which is basically this distance. Now everything in the priority queue is infinite except for the source node, which is 0. So we start with the source node and we take it and we check its neighbors. We take the next one, we check its neighbors, and once Q is empty, that means we visited all the nodes, and we can return our shortest path tree or whatever we need to return. So that's Dijkstras' algorithm in 5 minutes.